Hello everyone, I am Dr. Shobha Nikam. In this video, I'll talk about implementation of 3-variable K-map. So, K-map is nothing but graphical representation which is used for reduction of Boolean equations. So, reduction is basically needed to save space on the chip, to reduce power dissipation. See, let's take an example of one equation. Y is equals to, suppose, ABC plus AB. To implement this equation, I need one AND gate, 3 input AND gate, then one 2 input AND gate and one OR gate. But after reduction, here my equation will become AB in bracket C plus 1, anything plus 1 is 1. So it is equals to AB. So using single AND gate, I can implement same equation. So here, because of reduction, now instead of using 2 AND gates and 1 OR gate, I can implement same circuitry using single AND gate. So space on chip reduces. I need to apply power to single AND gate. So power dissipation also reduces. Then no extra wires are needed. Here I need to take one 3 input AND gate, one 2 input AND gate, and then their outputs will get connected to one OR gate. So here I need extra wires, and because of those extra wires, noise will get added. So the purpose of reduction is to reduce size, to reduce power dissipation, to reduce noise, and here speed also increases. Here delays are more. So for reduction of any Boolean equation, we can either use Boolean algebra, or the simplest method is by using K-map techniques. So in this video, I'll talk about reduction of Boolean equations using K-maps, and I'll implement 3-variable K-map. So let's see how to implement product of sum form. So I'll write simple equation function. Number of variables are 3. So A, B, C. Here A is my MSB, most significant bit. C is my LSB, least significant bit. And to implement POS form, product of sum form, I'll take some Maxterms. 0, 1, 4, 5 and 6. So here you need to understand, when Maxterms are given, these are also called as sum terms. So for these given terms, output is 0, and for remaining terms like here 2, 3, 7, for remaining terms output is 1. In case of K-map, number of cells in K-map are 2 raised to n, and here n means number of variables. So here number of variables are 3. So 2 raised to 3 is equals to 8. So number of cells in my K-map are 8. So I'll draw K-map for 8 cells. So here cells are 8. I'll write MSB first, A, B, C. Value of A can be 0 or 1. Whereas value of BC can be 0, 0, 0, 1, 1, 0, 1, 1. But here in K-map, we use grey codes, because in K-map, for reduction of equation, we form groups of adjacent ones or adjacent zeros, or overlapping ones or overlapping zeros. For that, there must be at least one variable common in two adjacent cells. So here 0, 0, 0, 1, 1, 1, and then here 1 0. In case of POS form, for 0 we take that variable as it is, and for 1 we take complement of that variable. Here what becomes, and these are some terms, so here it becomes B plus C. Here it is B plus C bar. Here it is B bar plus C bar, and here it is B bar plus C. So for given max terms, I'll put 0. So here value for this cell is 0 0 0. It means 0. For this cell it is 0 0 1 1 0 1 1 3 0 1 0 2 1 0 0 is 4 1 0 1 is 5 1 1 1 is 7 1 1 0 is 6. So 0 1 2 3 4 5 6 and 7. For given max terms, I'll substitute 0. For 1 0, for 4 0, for 5 0, for 6 0, and for remaining cells I'll substitute 1. Here I want my equation in POS form, so I'll make groups of zeros. So here I can either make group of 2 zeros or 4 zeros or all 8 zeros, and for grouping we must group adjacent or overlapping zeros. Overlapping means if I'll fold my K-map from here or from here, then this 0 and this 0 will get overlapped. This 0 and this 0 will get overlapped. So very first group I can make this chord. Then for this 0 there is no adjacent 0 here. So what I can do? I can make pair with overlapping 0. So my equation for this first chord is, here value of A is 0, here it is 1. So I'll skip A because value of A is not same. Whereas here you can see value of B is 0 here, here also it is 0, C is 0, 1. So whenever values are different, simply skip that variable. But if values are same, we'll take that variable. So B is 0 here, here also it is 0. So I'll take B because value is 0. For this pair, equation will become, see here value is A bar. So A bar plus, here in first column and in last column value of B is 0, 1. So discard B. What about C? C is 0 here. Here also C is 0. It means value is same and it is 0. So what I'll write? A bar plus C. So my equation will become, here B, this is product of sums. So this is my first term multiplied by A bar plus C. For these max terms, the equation is B into A bar plus C. See, if I want equation in sum of product form, then instead of making groups of zeros, I'll simply make groups of ones, and then I'll get my equation in sum of product form. So in this way, we can implement 3 variable K-map for product of sum form. Thank you so much everybody for watching.